This video is going to be about specific heat and an equation called mc delta T. Specific heat is the amount of energy needed to raise the temperature of 1 gram of a substance by 1 degree Celsius. And as you probably know from your own experience, different things heat up easier than others. If you take a metal spoon and a wooden spoon and you dunk them in a pot of water and you pull them out after the same amount of time so that they've absorbed the same amount of heat, the metal spoon is going to be a lot hotter than the wooden spoon is. And that's because it's very easy to change the temperature of metal, but hard to change the temperature of wood. The difficulty of raising something's temperature is called the specific heat. So specific heat is represented by the variable C, and the units of C are going to be joules per gram degree Celsius. So that's how many joules does it take to raise 1 gram of the substance by 1 degree Celsius. So now let's imagine that you have a sample of a substance and you want to raise the temperature. You want to heat it up by a certain amount. And we are going to say that the temperature increase is going to be represented by delta T, the change in temperature. And we're going to build an equation for the change in temperature. So the first thing that we need to know is how much energy is being put in. Okay, the more energy that is put in, the more the temperature goes up. So that is a nice, straightforward, direct relationship. The amount of energy we're going to represent by the variable Q, and so the greater Q, the greater the change in temperature. The more energy you put in, the more the temperature changes. Now the other thing, another thing that influences this is the mass. The greater the mass, the less the temperature will change if you put in the same amount of energy. So if you put in 1 joule, if you have a tiny amount, the temperature is going to increase a lot. But if you have a huge amount, the temperature is not going to change very much at all. So, picture a glass of water versus a swimming pool. If you put a certain amount of energy in, that glass of water is going to raise by a ton. The temperature will go up by a ton, but the same amount of energy is going to have very little effect on the temperature of a swimming pool. So mass and delta T are going to have an inverse relationship. So the M is going to be the mass in grams. And then finally we have to come back to the specific heat. And if something has a high specific heat, that means it's hard to change the temperature. So delta T and C have an inverse relationship as well. So that finishes off the equation. Now this is usually rearranged with some algebra to say that Q equals mc delta T. And a typical problem that might come up is something like if you have 100 grams of aluminum and you want to raise the temperature by 15 degrees, you want to increase the temperature by 15 degrees, then how much energy will it take in order to do that? So you have the mass of the aluminum, you have the temperature change of the aluminum, and you need the final thing, the C value for aluminum, which equals about 0.91. So you can plug all those values in, and so you have 100 grams times the C value, 0.91, times the delta T that you're looking for, which is 15. And when you do that and multiply it all through, you get 1365 joules. All right, just a straightforward example there for how you might use that equation. That's a quick introduction to specific heat and mc delta T. Thanks for watching.